Hello and welcome once again to maths problem solving sessions. The questions here relate to LCM, and I've taken them from the book Mathematics for GCSE and IGCSE. Now, though this is for GCSE, I think these questions are more towards the 13 plus exam, so I will be posting this video in the 11 plus exam question solved group rather than the GCSE one, because I think it's more towards the lower end, sort of GCSE, sort of the start of this book. So okay, so let's get started. So quite basic questions, but even then I think if for somebody who's doing 11 plus or 13 plus, it can be a bit tricky. So I'll get started. Okay, so the first question is a liter is equal to 1.76 pints. What is 5 liters in pints? And that will be multiplied. 1.76 times 5, that's 8.8. Okay, the next one, petrol costs 1.35 per liter. A car uses 9.2 liters during a journey. How much does this cost? So it would cost 1.35 times 9.2 is 12.42. The next one is action spends 71.42 at the supermarket. His receipt says he has saved your 11.79 on special offers. So if it's a special offer and he saved the money, so how much he would have spent if there are no special offers, it would be added. So you would have to add 11.79 to 71.42. So that's what I would have done. So without special offers, the money spent would be 71.42 plus 11.79, that is 83.21. Okay, the next question, a single pack of salt and vinegar crisps costs 70p, a single pack of cheese and onion crisps costs 65p, a multi-pack of 3 salt and vinegar and 3 cheese and onion costs £3.19. How much would you save buying a multi-pack instead of the equivalent amount in individual packs? So what we do is we have to add up the costs of the individual packs, and that's what I'd have done. And you see that the cost comes out as £4.05, and then we subtract the multi-pack cost from that to get 86p. So that's your answer. Next one is which number is a factor for all other numbers. So we know that 1 is a factor for all other numbers, so that's what I'd have written. Which two numbers are factors of all even numbers? So it's an even number, so it's 1 and 2. That's what I think. Which two numbers must be the factors of all numbers whose last digit is 5? So if the last digit is 5, it's divisible by 5, so it's 1 and 5. Which four numbers must be factors of all numbers last digit is 0? So if its last digit is 0, it's definitely divisible by 10 and 5. And then the other one is 1, and also if it's 10, it would be divisible by 2 because an even number is 1, 2, 5, and 10. Okay, the next question is for each of the following. Please find a factor greater than 1 but less than the number itself. So greater than 1, okay, for 4 it has to be 2, right? So for 14 it has to be 7, it can also be 2. Okay, for 34, but I think you have to find a factor of 1, so 34 it's 17. 2 times 17 is 34, and for 74 it is 37. Okay, so explain why any number with last digit 4 cannot be a prime. With last digit 4 cannot be a prime because it is divisible by 2, and if the last digit is 4, so it will have two factors. It will have definitely have two factors, 2 and 1, and also if its last digit is 4, it can also have 4, like 4 is divisible by 4, and it can, or 6, so it can have not all of them, but 4 or 6 can also be its factors. But 2 is must, 2 is a factor for all numbers. So if it is a prime and it has two factors, then it cannot have two factors. It will have only one factor, the one and the number itself. So here you have definitely got 3 and more factors. Okay, so it cannot be a prime. Okay, so that's what I wrote down. Last digit is 0, meaning they're all even. Factors of 10, not a prime. Okay, so without doing it, number 6, without doing any calculations, explain how you can tell that none of the numbers in this list are prime. So that's the answer is the same. Oh, sorry, I said this answer first before. So, but yes, so initially that's the reason why it is. So is Lawrence and Naima cycling around a circular course. They leave the start line at the same time and need to do 10 laps. It takes Lawrence 8 minutes to do 1 lap and Naima 12 minutes. After how many minutes does Lawrence pass the start line? Write down all the possible answers. So what we have to do is Lawrence is 8 minutes. So what we will do is we will write down the multiples. So if you do the multiples of 8, you will get 8, 16, 24, 32, and so on, but only up to 80, because it takes Lawrence 8 minutes, and 8 times 10 is 80. So it will take up to 80. We will do the multiples, so the possible the times when Lawrence will pass through this start line will be 8, 16, and so on. Okay, the next one is how many times does Naima pass the start line. So it's a very similar method. You will have to find the multiples of 12, and then that would be, it is we write all the multiples up to 120, and then for C, what we will do is when do they pass the start line together. We have the LCM of 8 and 12 and 24, so they would pass the start line together in 24 minutes. Next question is Mike visits Oscar every 4 days, while Lorinda visits Oscar every 5 days. If they both visited today, how many days would it be before they visit on the same day again? So they would visit on the same day again, which is the common multiple of 4 and 5, and the multiples of 4. So I write, and then I do the multiples of 5, and the lowest common multiple is LCM is 20. So that's your LCM 20. So that's your answer, the question. So okay, the next one is a garden center has between 95 and 205 plotted plants. They can be arranged exactly in rows of 25 and exactly in rows of 30. How many plants are there? So this one, once again, we'd have to find the multiples of 25. That's less than 205. Okay, so it's more than 95. So we can't have, we'll start from here, and the multiples of 30, again we'll start from here because it has to be more than 95. Okay, so then we will do that there are 150 plants, which is a common multiple between 95 and 205 is 150, so there are 150 plants. The next question is there are between 240 and 300 decorated plates hanging on a wall, and the number of plates divides exactly by both 40 and 70. How many plates are there? So once again we will start with multiples. 40 between 240 and 300 is 280, and a multiple of 70 is also 280. Okay, so the answer is 280 plates. Next question, Jill divides a pile of sweets into 5 equal piles. Kay then divides the same sweet into 7 equal piles. what is the smallest number of sweets that could be? The smallest number of sweets will be the LCM. So we do multiples of 5, multiples of 7, and my lowest common multiple is 35. So that's the smallest number of sweets. Okay, so hopefully this helps a little bit in doing word problems related to LCM and HCF. Thank you for your time, and we'll be solving many more questions soon. Thank you.